Okay, so last time we left off, right, we were working on our iterators for our range class. And what we wanted to do is we wanted to see if two iterators were the same. So the first thing that we said is that the two iterators had to be iterating over the same range, which is what this line says. And hopefully this week we'll cover what the ampersand operator in this location means. Besides being over the same range object, what else would they have to be equal? They'd have to be at the same position inside that range, right? So else if, let's see, if our position is equal to the right-hand side position, we can return true. One other thing that we should kind of consider, not sure why that's complaining at me. One other thing that we should consider is if two iterators are out of bounds, should they be considered equal or should they be considered not equal if they just happen to be out of bounds? So who says that two iterators over the same range that are both out of bounds, like they're two iterators over the same range object and they both happen to be out of bounds, they should be considered equal? Who thinks they should not be considered equal to each other? Okay then. We will find though that if we don't define two iterators as being out of bounds, it's not going to necessarily work correctly. We'll see that happening in a little bit. So here we might just say else I have no idea why it's complaining about this. You guys see any syntax errors over here? See if I can just get it to complain at me a little bit better. Oh, well, I guess we do have to get that to finish up. So leave that alone for now. So how might we I guess I currently have to type that one out myself. How might we implement not equals? How might we implement not equals? Yeah. Oh yeah, if equals, right? So return not star this equals right hand side, right? Okay. And that looks like we've implemented all the things that I wanted to. The less than, greater than, less than or equal to, greater than or equal to, right? Those should all be fairly easy to figure out as to what would need to happen to make those. You would just more or less be comparing the pauses, right? So now if we pop back over here to range, so here we have begin and here we have end, and they both need to return range iterators, right? One thing to think about as we're over here, do we need to include the range iterator class here from what we talked about last week? Yes, we need to include it. No, there's no need to include it. So for those of you who say, yes, why do we need to include it? I'm going to ask the no people the identical question, so don't think you're wrong just because I asked you. Because we're using an instance of the class, and for those of you that say no, So we can actually get away with not having it because we were returning an instance of the class. We don't actually have an instance of this class inside this file. So we can just say, how would we do a forward declaration of range iterator? Just class range iter semicolon. And then this could be moved into the range class over here. So here we have begin and end. We should be fine with that. Why are you not auto-completing? So what would we have to do to create an iterator to the beginning of my function? So we'd have to return, right? We need to create a range iterator, and it needs to be an iterator, again, over who? Ourselves, right? So start this, and we can give it a position to start at, or if we don't give it a position to start at, right, it will default to the range start. No, that must be something over here that's messed up with my .h file that I can't see. Oh no, that finishes. And nothing over here looks bad. Anyway, we'll let it complain in a little bit. There really is things. So we can return an iterator over ourselves. I do include that. The inside a namespace. No, inside a range namespace. Okay. Something's just going weird with CLine right now. So we can just return an range iterator over ourselves. Does this make sense? Yeah. It needs to be when you forward declare a class, it needs to be declared inside the namespace that class exists. So given that range iterator over here is declared inside the global namespace, if you're going to forward declare it, right, like we did back here in range.h, that's probably what my problem is. Thanks. Should it be in the global namespace as well? Also, vice versa reasons, because the range class is inside of the global namespace, the forward declaration comes before the class. And then we have to return an iterator to the end. So again, we want to be over ourselves, but what positions should we be at? Should be at the end, right? So get range stop. Remember that when you're creating the iterators, the element for the end is, one element past the end, whatever that happens to mean, right? Because it should be out of bounds, because all of the functions are going to run up to, but not including the end. So the end needs to be out of bounds. Yeah, there's a semicolon there. Let's see if we can build now. And then back here in main, in addition to including range, we're going to need to include a range iterator. And This is line 48 of range iterator. Oh, did we not do? Okay, this was the generic version. For the non-generic one, we can just do something like pause plus equals range dot get range step times the right hand side, right? We can just multiply the step by that much instead of having to go through a for loop where you go plus 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 plus, and then we can return ourselves. So that would allow you to do a fast advancement by some number of elements inside the range. So here's main. So we create two range classes. Then you can see that we do like R1 equals begin, it doesn't equal end, plus plus iterator, print it out. But notice that we can also do like the for each loop. This works because we have that begin and that end statement, right? Because we have both of those, right? This ends up working out. If you don't define begin and end, you won't be able to use it in this manner here by iterating through the container. Also, for this to be able to work in all contexts, right now, the begin and end, back over here. The begin and end, do they modify us? No, they don't. So they should probably have const at the end. That would allow them to be used in all situations, both the const and the not const version. The other thing to also consider is if you want to be able to have an iterator that can modify and both not modify, you would need both a const and a non-const version of this function here. And you'll see this showing up in a little bit. So now if we go ahead and we try running our code, we can see that we have like this infinite loop happening. Right, it just keeps on going. And that one's probably going to start happening fairly soon. So you might say, like, can we get to this breakpoint? There's a breakpoint here, we debug. So we're able to print out the first set of values. Then let's see if we can get to the second set of values. We resume. We got to the second set of values, and you can see that they printed out 5, 6, 7, 8, 9. This is when we're iterating through range 1. So we're going from 5 to 10 by 1. But this backwards one doesn't end up working because of how we define the equality as well as like the not equals. Remember that we said two iterators have to be the same, right? If their positions are the same, right? And we made it so that end was at the stop, right? So end in this case is going to be at position 1. If we go through the values though, right, we're going to start at 10 and we're going to count down by how much each time? 2, right? So it'll be 10, 8, 6, 4, 2, 0, -2, etc. But we should stop at which element? So if we were printing this out, what would be the last element that would be printed? The 2 should be the last one, all right? Because the 0 should be out of bounds. But when we go to compare the end, right, with where the iterator is currently at, this iterator is at 0, right? Where's our stop at? It's at 1, right? So is 0 equal to 1? No, but are they both out of bounds? Yes, this is why I mentioned earlier it may be useful to have it when we do our equality comparisons. If they are both out of bounds, just say they're both equal if they're over the same range, and this will cause us to stop successfully. So if we go back over here to the range iterator, and we change our operator equals to have another else if in here. So if we say else if, right, not star this and not right hand side, return true. And again, remember we wrote this not operator back here that returns not of the bool. And the bool is like, hey, are you in bounds? Right? So if they're both out of bounds, we're not good. Or if we're both out of bounds, they are equal. And this should fix our problem. And now it stops, and you can see the last thing printed out was the 2. That was just something to watch out for, because most of the equality comparisons, right, are done while you're not equal to the end. So a lot of times, if you just go straight out of bounds, you should be considered equal to each other. Do you guys have any questions on iterators before we move on to our next topic? Oops. Okay, I got it over there. With the winner one right now. Okay, so we're going to talk about Git, and hopefully you guys all start using it after this. It's a really useful and powerful tool that's used definitely industry-wide or some other version control system. So taking the time to learn how to use it will save you a lot of time, both now and in the future. So Git is a distributed version control system. A version control system is a program that's designed to help you deal with multiple versions of a project. It doesn't necessarily have to be a coding project, though we're probably going to be using it in this class strictly for that, right? You might have different versions of a book or a video or a digital image, right, at different points in time, and you want to be able to keep track of all of these different versions. It's distributed, so everybody gets a full copy of the project, which means there's no single point of failure. With like a centralized control system, like the main thing is on one server, and if that server goes down, it's gone, and no one can access it. But with Git, everybody has a copy of a project, so as long as one person has it, you'd be able to restore it. So some reasons why you might want to use it. If you've ever had an idea in your program that you wanted to try out, or you wanted to try rearranging or reformatting some code, but you were afraid that change might screw up everything up, Git is the perfect thing to use here. If you've ever ended up with multiple versions of a file or folder, I have version 1 of my project, version 2, version 3, version 4, version real 4, version real final, right? That's where you're going to want to end up using Git. If you ever wanted to be easily to go back to an older version of your program that you knew was working and was bug-free, to kind of figure out where your bugs might be showing up. If you ever wanted to be able to collaborate with other people more easily, Git's also nice. If you ever answered yes to any of these questions, which I imagine most of you have, I know I have answered yes to probably every single one of them, then Git can definitely help you out and make your life easier. So you can download Git here, but if you've already followed the setup tutorial, then you will already have Git installed on your machine. So once Git is installed, you're going to want to set up some parameters. So here's what you would do to set up your username or your email. You can also just skip this step right now, and the first time you commit inside of CLine, it will ask you to set these parameters. There's also a list of other options that you can set, and there's a list there. Hopefully you guys all did this reading already. If you want to enable Git in CLine, it's File, Settings on Windows, then go to Version Control and click Git, and then specify the path to your Git executable if it isn't already set. Right, that'd be like File, Settings. Then we would go to Version Control. Then you'd go to Git, and you'd say, hey, where's your path at? If you're also planning on using GitHub, now would be a good time to get your account linked. So you can go down here to GitHub and then add a new account. So you won't have one by default, and that will link your GitHub account with CLine, so CLine can push changes to any of your repositories or pull things down as well. So I'll show you how to do a couple of these different things in both CLine and on the command line. So if you want to create an empty repository, you just do git init, or if there's already some project that you know that you want to be using and you want to do your own modifications, it'd be git clone. Here, the first thing that you would do would be to make a directory where you want to hold your repository. For CLine, once your project is up and running, version control, enable version control integration. It'll start up Git for you. Select Git. If you already have a project from online that you want to download and bring in, you go to the CLine start page, you say check out from version control, select Git, enter the URL that has the repository on GitHub, and then select the local folder that you want to be copied into. So a Git repository are the files that make up the project that are being tracked by Git, as well as snapshots of those files at different points in time, and also the changes in the history of what's been modified from going from one step to the next. 2 and 3, these are going to be kept hidden inside a folder called .git that's inside the project directory. If you want to add a file to the repository, it's git add. You list your file names. You have to do this command for all new files and all files you've changed since your last commit. In CLine, you would right-click on the file and then go to Git and then Add, or your shortcut is Control-Alt-A. For the CLine, you only have to add the file once, and then when you do a commit, it will automatically add it in. And what this is asking is that for Git to keep track of the changes since the last time you made to that file. If it's a new file, it will include it in there. So let's try opening up an example. I think because Google is doing stuff in the background, it's making things really slow. I'll just make a new project. We'll create this somewhere that's not going to show up. So if you want to start a new repository, again, it'd be version control, enable version control integration, Git, say OK. The Git repository was created. This looks like I accidentally just not make a CMake list. Every time you create a new file, it will ask you if you want to add it. Yeah, I know. I tried creating a new file. As you can see, it's not letting me create files for some reason. Yeah. Okay, it's there now. So if we want to add our files, we can select them. Say right-click on them. Say Git add, and you can see the color's going to change from being like that orange color to being like a green color. The green color means that these files have been added to Git for it to start tracking, but Git's not tracking it yet. When you do your next commit, Git will save them. To add files, the shortcut command is Control-K or git commit, and Git will prompt you for some message that you'd like to add to show up on the commit details. It's going to take a snapshot of all those files, and then once that commit has been made, you'll be able to go back to it at any point in time. So the closer you make your commits in history, the more fine your version control will be, and the easier it'll be for you to go back and get something at a certain point of your time. If you're doing tons of work all at once, right, and then you make one commit, well, if you want to go back from your current commit to your previous version, a lot of stuff is going to change instead of just a very small amount. So commit very frequently in your code. There are going to be quite a few files, though, that you don't want to be tracked. And so what you can do is add a .gitignore file. Some types of files you'd want to ignore would be like generated files or build files or temporary files. Git will warn you about those files not being tracked every time you commit. The gitignore will be like, hey, Git, we really don't want to be including these files that just happen to be inside this directory. So you're going to write your file. It's called .gitignore. Blank lines are ignored. Lines that start with a pound are considered comments. A exclamation in front of a pattern will negate it. A pattern that ends with a slash will only match a directory that has that name. So if you did bar slash, it would be the folder bar, not the file bar. Regular shell glob patterns have the normal meaning. So star means 0 or more characters. A question mark means any single character. Or if you put characters in a set of brackets, it's going to be any single character inside that set. Some special patterns, the star star. So pattern slash star star means everything beneath that directory. So if you have my dir slash star star, it's anything inside my dir. Star star slash means in the pattern means in that that pattern that will match inside any of the subdirectories. So star star slash my file means any file beneath the current directory whose name is my file. So all the way down as far as you go, anywhere that happens to be a file named my file, it's going to ignore it. Or if you wanted to, you could do something like star star slash star.txt, and that would ignore all files that end in .txt that are beneath this subdirectory. A star star slash B means any file named B that is located somewhere beneath directory A. So some ones that you're going to want to ignore We have to get a new file, and we'll do .git ignore. It's text. So we'll want to ignore this file. We do want to add it. The cmake-build-debug. That's where all your build files are going to show up. So I'm going to ignore everything in that directory. And I also want to ignore .idea. So .idea is a hidden file here that's created by CMake that we're not interested in having stored. It's what shows like how things should be rendered inside your project. So now that we're ready to add these files to our commit history, we can do like Control K, and then you can add some message like first commit. And you can see here there's a list of unversioned files. These are the ones that we're ignoring. For example, there's like a .game or a .name, a get example, right? These things aren't being added, and we're completely okay with that. So we say commit, and that has now made our first commit. So we made our first save point, and we can go back to here to our project at this point in time, anytime we want. Any questions so far? Yeah. The commit. So you only have to make the ignore file for like a single project, but you would have to make it every single time you create a new project. And you only have to list files in there that you want to be ignored. Right? So most of the files you're going to be creating, you won't want to ignore, but there's just that set, the cmake, build, debug, and the .idea that we don't want to pay attention to. So here's some examples of some git ignore files that are a little bit more complicated. Ignore all temporary files. This means any file below the current directory that happens to end in a tilde. So some editors will make files that end with tilde for temporary files. Ignore all hidden files, */ /.*. So any file that begins with a dot, we'd ignore, except for git ignore, not .git ignore. So ignore all of these guys, but not git ignore. So sometimes what you want to do is you might want to create a new branch. A branch is when you want to try out something new, or you might want to add some new features. Command line is going to be git branch, new branch name. And by default, when you run this command, it's not going to switch you to the new branch. It'll just create it, and you'll end up still on the old one. If you want to create and switch to it using the command line, git checkout -b, new branch name, and it'll switch you over. And C-line, version control, git new branch. C-line will give you an option, a little checkbox. Do you want to switch to this branch or not? The branch will be a copy of your project from where you decide to branch out from. Exactly everything that's there. And again, branches are great for when you want to try out new ideas and see if the features or the changes you want to make are going to work out well. And if they don't, you can discard the branch. If you do, we'll talk about in a minute, you can merge those changes back in to your main branch. I would recommend adding a new branch every time you try to add a new feature, or anytime you want to try refactoring your code. That's going to give you that backup point, because you have to do a commit first before you can branch to get back to your code at this point in time, and you can switch between these two. It's also very nice if you're working with a collaborator, like you and one other partner. You can have a main branch, which is like your final version, but you and your partner can create your own branch, right? I might be working with somebody named Sally, so there might be like a Matthew branch and a Sally branch, right? And we might both do things on our own branches, and once we feel like what we've done is good and complete, we can merge it back into the main branch. And then our partner can be able to get those changes from there. Our partner would also have access to our personal branches if they wanted to. So over here, we might just do something simple like std : cout, hello world. And then we might, make another, said hello. And now we'll be able to get back to our project at this point in time. But now we might, for example, want to create a Spanish version. So you can create a new branch. So that's version control, git branches, new branch. And I might call this like a Spanish branch, for example. And I don't think I showed you closely enough there. Skipped over it. Branches, new branch. You can see there's this little checkbox down here, like, do you want to check out that branch? Do you want to switch to it? And you can see which branch you're on, by looking down here in the bottom right hand corner. So I'm in the Spanish branch right now. So now we might want our Spanish version, which says like, forgive my poor other language skills, but we might change our line of code now to say like hello mundo, right? So it says something different here. And then we can make a commit and said hello in Spanish now. We can say commit. And now if I want to switch back to my previous version, again, I can go to Git branches. The shortcut is Control-Shift-tilde. And if I switch back to my master branch, which was the English version, right, it went back to my previous version of my program where it was at right here. And then I can switch back to the Spanish version if I wanted to later on. So on the command line, it's git checkout branch name to switch to that branch, and you already just saw how to switch to the new branch. Before you can switch to the new branch, your current branch must be clean, which the easiest way to make that happen is to do a commit. A clean branch means that there haven't been any changes since the last commit. And CLine and Git will both give you a warning if you have changes that you've made to your files in this current branch that you haven't committed if you're trying to switch to a new one. So one benefit of Git is that it makes remote collaboration a lot easier. To help facilitate this collaboration, it's useful to have a server to hold your projects. So you might have your projects hosted on GitHub. If you do plan on using GitHub to work with your partners, make sure that your repositories are private. Repositories that are private are only accessible to you and anyone else that you decide to share them with. Public repositories are accessible to anybody. So it could be possible that if you did make your solution public, some other student in this class or future classes could go there and copy your code, right? And then submit it. And then you end up getting in trouble, right? So make sure that every time you create any repository on GitHub for any classroom use for this class and the other ones, you make it private so that nobody else ends up copying your code. GitHub just hosts Git projects, and it doesn't have to be used with Git. So if you only want to be using Git on your own local machine, it's not necessary to have a GitHub account. GitHub is just hosting that project somewhere in some server so that people at other locations can access it. GitHub should be, from what I've heard, has now released private repositories by default. If not, though, you can search for like Git student account or like GitHub student account. And for student accounts, you do have access to free private repositories. So let's go make a repository on GitHub. So I might go create, so I have this project over here, which is one that I've done from earlier, but maybe I want to go and delete this project. Should be down here. Delete this repository, enter its name. Bye. So if you want to create a new repository, you say new. And then, this might be called like example Git. Again, making sure that you make it private. Really important. Create your repository. There's nothing here right now, but we can copy this guy to our project now. So I've just copied it to my spacebar. And so what I would do is I could go version control, git remotes, and this is how I'm going to link my project right here with the one that's over on GitHub. So you click add, enter it in. It'll go check our URL to make sure that's good. Great, we're linked. When we want to go put changes up onto the repository on the server, we go to version control, git push. And as we push things there, if I come back and I refresh the page, voila, my stuff is there. right? The only branch though that I pushed was the master branch. So the Spanish branch is not there because I haven't pushed it up yet. The other thing to think about though is before you do your pushes, you want to make sure that any changes that your partners have done, that you pull them down. So you would do this by pulling. So you can use git fetch. Git pull is shorthand for git fetch, git merge. Git fetch just kind of like brings down the changes, but doesn't integrate them in. Git pull will pull down the changes, and then you'll have to merge them into your current project. Merging in a second. For C-line, git fetch, and then version control git pull. Again, fetching will get down all the changes since the last time you fetched. Once those changes have been brought down, you can inspect them and merge them into your project as you want to. Pulling, though, is probably something you're more likely to do, which will download the changes and then again attempt to integrate them into your project. When you're pushing, it's git push or version control git push, just how you saw. It'll go push your changes up there. And again, before you push, make sure that first you have to make sure that you commit. Otherwise, you won't be able to push. Also, make sure you pull down any changes your partners would have made, integrated them into your own, and then you can go make another commit and then push. So merging is probably the area where things are going to start to go wrong for you when using Git. This is how you take different versions of your project and kind of like combine them together. So in the command line, it's git merge and then branch name. This will take whatever branch name that you specify and attempt it to merge it into your current one. Merging will take those changes and then incorporate them in. There are two types of changes. The first is a fast forward one. This is one where just like the newer branch that you have, the branch that you have is newer than the old one, and those changes will just be merged in. That one's really easy to do. The conflict ones are more harder, and these are where different versions of the same line have been changed, and you have to pick which one that you want. Apparently, we're out of time. We'll talk about this tomorrow, wrap it up, and then we'll get into pointers.